Good afternoon, everyone. My name is Dr. Eric Turing. I'm the Senior Vice President for the American College of Veterinary Preventive Medicine, and I want to welcome you today to today's continuing education webinar. This webinar is sponsored by the American College of Veterinary Preventive Medicine and our partner organizations, the National Association of Federal Veterinarians, the American Association of Food Safety and Public Health Veterinarians, and the U.S. Animal Health Association. This time, it's my pleasure to turn over the microphone to Dr. Suzanne Thomasy, the chair of our ACVPM Continuing Education Committee.
Thank you, Dr. Turing, and welcome, Dr. Bischoff. Dr. Karyn Bischoff is a diplomat of the American Board of Veterinary Toxicology and is the diagnostic toxicologist of the New York State Animal Health Diagnostic Center. After receiving her DVM from the University of Illinois, she completed a toxicology residency at Oklahoma State University and a pathology residency at the University of Florida. She was privileged to serve on multiple committees, including as president of the American Academy of Veterinary and Comparative Toxicology and chair of the AVMA's Committee on Environmental Issues. She will complete her Master's of Public Health in 2022. Thank you and welcome, Dr. Bischoff.
Hi, and I should probably add I'm on the Food and Feed Safety Committee for the U.S. Animal Health Association with Dr. Sanders, who's also on the call. So I was very happy to see him, and I think I saw Dr. Alroy and a couple of others that I've some names that I've seen around. So that's very cool, and I'm glad to, and a whole bunch of people whose names aren't that familiar to me, and they just keep coming. So very excited to be here. So I'm going to talk a little bit about pet food recalls and product safety, and it actually came at a good time because I'm writing a blog about it for one group and actually working on a grant proposal for the FDA for another group. So it's been at the focus of my week so far. So this is good timing for me. So, and I actually, this has got some slides from another presentation that I did for a certain pet food company who shall not be named here, but if you see some product placements, that's why. So I apologize for that. At some point, and some of them I actually went ahead and inverted the slides so that you could, unless you could read backwards, it wasn't quite so obvious. But I forgot to do that in this particular case. So pet food recalls and safety. I'm going to talk a little bit about specific recalls and some of the processes behind recalls, and then blending in with some of the different recalls. I'm going to talk about some of the contamination errors and formulation errors that we've seen, and then I'm going to talk a little bit about hazard analysis and critical control points used in pet food safety. So recalls. I'm going to put this out here, and if anybody wants to chime in, that is wonderful. Basically, a little bit of a quiz. What is the most common cause of pet food recalls? And the questions are: is it a mycotoxin? Is it adulteration, formulation error, or bacterial contamination? And I don't know. I got a C. I got a B. A lot of B's. And this is a misleading question because I'm actually, the most common cause is actually the one that I'm not going to talk much about today because I'm a toxicologist, and it's those crazy microbes. So, so unfortunately for me, but honestly, we are seeing a lot of toxicology involved ones as well. Only about 1.7% of small animals poisonings were attributed to food. Pet foods were less than 10% of recalls in 2011, and this is actually a more recent data showing the breakdown of pet food recalls. And honestly, right now you can see that bacterial contamination is only about half right now. 53%. The rest is chemical adulterants, formulation errors, other adulterants, and then just like mislabeling and things like that, labeling errors and things like that. So there actually are quite a few more pet food recalls, and this doesn't include the big aflatoxin. And this is just, I broke down some of the major contaminants that we saw in 2018 and 2019. So you can see Salmonella and Listeria, Salmonella and E. coli are the big ticket items here on the bacterial side. But then you look over here and foreign material, that could be little flakes of metal, little pieces of plastic, anything weird like that. Unspecified, it just said chemical contaminants on the FDA's website. I don't know what that means. And then barbiturates were another big one. So these are normally very trace concentrations because some rendered animal got into a big batch that was made by a commercial operation, but there have been some incidents where with small batch producers of pet foods where we've gotten into significant problems with pentobarbital. Formulation errors, vitamin D3 is a big one, but I do see a lot of thiamine errors, and I think they're probably underdiagnosed. And it's not really so much an error, it's because thiamine just degrades so easily in the pet food processing that it's hard to supplement enough that it actually makes it through the processing program. Copper, mostly a large animal issue. Monensin, again, a large animal issue, and NPN. And honestly, I just had a urea case come through my lab. So that is a potential issue in large animals. Natural contaminants, we had a huge aflatoxin outbreak last year. It started in 2019. And then thyroid hormone is one that seems to come up as well. So they actually, when they're taking rendered animals, they'll actually take thyroid tissue accidentally. It doesn't get left out. And then compliance stuff. So does anybody know what the contaminant in the sport mix Midwestern pet foods recall was? Is it deoxynovalenol, also known as DON, also known as vomitoxin, thyroid hormone, aflatoxin, or pentobarbital? Can you get guess? Oh, I think every one of them has been guessed now. Somebody said several people are saying it's aflatoxin, and they seem to be fairly confident in that, and they are in fact correct. It started in the Midwest. It was first diagnosed by the diagnostic labs in Missouri and the one in North Dakota, who are the premier mycotoxin testing laboratories in the country. And that came through the FDA. So if you suspect a pet food recall, super, super, super important to get labels and things off of the bags. And this is harder than you would think, because a lot of people, and I do this myself, will just dump the bag into another container and they don't keep the old bag. And the other issue is that and this is always a problem when we're dealing with feeds, is that the food that made the animal sick is gone. You don't have it anymore because it's either gone out in the cat box or in the yard or in the compost pile, but it's no longer available for your testing, and at least not in a pristine condition. So what you're left with is a sample that is from possibly the same lot and possibly not of feed. And it's so you have a bit better chance if you're dealing with a Chihuahua whose owner gets the 50-pound bag of dog food versus St. Bernard whose owner gets the 16-pound bag of dog food, right? So it's really easy to, it can be really hard to get a good sample. Lots of container lot numbers. If they can bring the whole container in, that is fabulous. And I will get back to the question in the chat a little bit later today. I promise. So we'll work our way towards how we prevent some of these issues. So if you have dead animals, of course, a good postmortem investigation is super important, and then antemortem testing. And a representative sample of food is hard. It can be a little bit challenging, again, because the perfect sample is the one you're never going to get. But if it's aflatoxin or another mycotoxin, for example, if it was mixed in with the ingredients, it might be homogenously throughout the bag. But if the bag, and we had a case in Texas years ago where it was not in the feed ingredients, it actually occurred in storage, where the bags were in a very humid, hot warehouse for a long period of time. And so you got spotty, hot spots of mycotoxins in there. So it made testing the feed kind of challenging. So here are some of the antemortem samples, basically anything that you can get without a whole lot of poking. So a little blood, a little serum, urine, vomitous lavage fluid. Yeah, save the vomitous, please, please, please save the lavage fluid. This is more useful usually in like a single point source poisoning than in a pet food poisoning, but it can be useful. Feces, postmortem samples, all of this stuff, just a complete postmortem set for formalinized tissues, half a brain, and then little 1 centimeter thick slices of all of these other things. No more than 1 centimeter thick for the pathologist, or they'll get mad at you. Fresh and frozen samples, brain, liver, heart, kidney, blood, GI contents, and these better be more than 1 centimeter thick, or else I will get mad at you. We need large samples for toxicology because most of our methods use up the sample, number one. And number two, if we test for something and use up most of the sample and then we have to test for something else, we're kind of out of luck. So large toxicology samples, we really, really appreciate that. So moving on a little bit to some specific issues. So what are some possible ways a pet food can get contaminated, either through a natural contaminant, fungal or microbial toxins, things like that, through an error in the formulation, an ingredient wasn't in there in the right way, too much, too little, not there at all, or adulteration, something got into the food that's not supposed to be there. And I think everybody's kind of turning on to this is an all of the above situation. Any of these things can be a problem and have been problems historically. We really didn't see too many adulteration problems except for the occasional low concentration of pentobarbital back in the 70s and 80s, but then all of a sudden 2007 changed that for us. So what I'm calling natural contaminants are mostly microbial things, so mycotoxins, and then thyroid hormones. So that happens when the carcass that's used, they don't remove the thyroids, and we can get pretty high thyroid hormone in some of these guys. So these are some of the aflatoxin outbreaks. There was one in 2005. I thought I'd updated this and I guess I didn't. The last one was in 2020. And this was the one, 1998 was the one in Texas where it actually was a storage fungus that was an issue. It was actually the bags got contaminated while they were in storage. Deoxynovalenol is another mycotoxin that's of importance. So aflatoxin is the big bad mycotoxin everybody thinks of when they think of mycotoxins. Deoxynovalenol is the one that's called vomitoxin. It supposedly makes pigs puke if you can actually get them to eat the contaminated food, which is the first challenge because they will refuse it. In dog food and cat food, it occasionally causes problems. Usually it's a self-limiting gastroenteritis. So the pet food company replaces the bag of food, pays maybe some minor medical costs, and pays them to clean the carpet of the house. And that's basically what you're going to end up with. But that can add up after a while. And then back in the 70s, there were some aflatoxins cases associated with peanut meal being used in pet foods. And Aspergillus is just, it's a beautiful organism here. And it basically produces a few different mycotoxins, but the one we're going to be focused on is going to be aflatoxin, and that's the big bad mycotoxin. So with something like deoxynovalenol or something like that, we think, part per million concentrations, and part per million is a lot. A part per million is like spitting into a swimming pool. Okay. So it's a pretty big dilution factor. With aflatoxin, we're talking in parts per billion with a B. So that's like spitting into the Erie Canal. Well, at least a lock on the Erie Canal. I mean, these are very tiny, tiny concentrations. And it's found in all of these wonderful things that we like to eat. So it's kind of depressing. It's in peanuts, sometimes in peanut butter. They occasionally find it in Doritos and other corn chip type things. Sesame, cocoa beans, hops, I believe, can get it as well. Barley can get it. So definitely an issue. And again, sampling is an issue with some of these mycotoxins. So whether you are sampling a bag that's been in storage that had mycotoxin production in storage, where you've got a hot spot in one area and the rest of the feed is clean, or you're the pet food company that is sampling a train car load of corn that's coming into processing, how do you make sure it's clean of aflatoxin? You have to take many, many samples. And it's challenging. I mean, you have to take samples from different areas. If you see one area that looks worse, that's your worst case scenario sample. But it can be really challenging to get a really good sample on these things. I put the bag of oranges here, and this is the blue cheese showing how, that it kind of grows in focal areas. The oranges, I always remember oranges when I think about mold growth, because like I'll buy a giant bag of oranges, and I love oranges, so I always have a bag of oranges around. And every now and then you reach in there and your hand goes squish and you pull it out, and like you have this one green fuzzy oozing orange, and all the other ones look perfectly fine. And you're thinking, well, was it like that when I bought it? How long has it been like that? Did it happen since it got home? But yeah, I mean, it can be hard. I mean, you can just have one hot spot of growth producing mycotoxins, and the rest of the sample seems to be pretty clean. So it can be challenging. And that is where we've run into problems historically with pet food manufacturers, where they do sample the load of raw ingredients, because you don't want to have to throw away 1 million pounds of pet food because you use contaminated raw ingredients. But then they may not sample the stuff that comes out the other end of the pipeline. So that can be a little bit of a challenge. So some basics on aflatoxin. This is my Simon Puppychon when he was a baby. 60 part per billion, again, part per billion. These are tiny, tiny, tiny concentrations that can kill a dog after a few days of eating that feed. The LD50 is about 1 mg per kg, and I always give my students, try to figure out how many kgs of feed they have to get to 1 mg per kg in my dog. And it sounds like a lot. So I think this 1 mg per kg is probably a little bit higher than it needs to be. But they are sensitive in tiny amounts. There are no clinical reports of aflatoxicosis in cats. They are probably equally susceptible as dogs. And I think the reason we don't see it in cats is just because if you've dealt with an aflatoxin outbreak, one of the major primary complaints is feed refusal. So these people will try to do weird things to get their pet food, their dogs eat food. They'll put gravy on it. They'll mix it with butter. They'll do other things to make it more palatable, because for some reason the dog won't eat it. Cats can't be tricked that way. They'll just lick all the butter off and leave the nasty kibble there. So I think they're less likely behaviorally to get aflatoxin poisoning. Pregnant animals, and I know that the Missouri group has looked a lot into some of the effects on pregnant bitches that were affected by aflatoxin, and they found some of the pups were born smaller and didn't grow as well, just poor doers. Young males and certain individuals have increased susceptibility. This is your aflatoxin molecule here. Rapidly absorbed. It doesn't really accumulate in tissue, so it's really hard to test the dog for aflatoxin. When you think, first you're dealing with 60 part per billion with a B, okay? And then you're diluting it even further in the body, okay? So 60 part per billion in a kilo of food in a 50 kilogram dog. And then it's eliminated almost 90% within the first 12 hours rather. So it's not hanging around in the tissues. So finding it in the tissues of the dog is going to be really, really hard. But what happens is, if you see this little double bond up here on the, let's see, I don't know if you see my pointer, but on the far left and top left there of that molecule, there's a double bond there. And what happens is when the body metabolizes it, it breaks that double bond and it sticks an oxygen here. So popularity of grain-free dog food, this aflatoxin grows on a lot of other stuff besides grain. So that's a problem, but also you have other problems associated with grain-free. But I think some of the aflatoxin outbreaks and the melamine outbreak have really put a lot of pressure on the pet food industry to try new things for better or for worse. And yeah, there is a question in the Q&A as well. How do you submit? Are there any specific particulars for submitting, shipping, packaging? My big thing, I would definitely, and I'm going to talk about this a little more later, I would definitely contact the FDA VetLearn account. FDA VetLearn will help you with deciding what testing to do and paying for the testing if they have a significant if they have confidence that you are dealing with a real pet food contamination issue, they will probably assist you. So call the FDA's hotline for veterinarians. And I would say with most of the contaminants that we deal with, like if it's if it's a canned food or something, most of the ones I deal with are dry foods. For dry foods, you can send them dry, cool, and ship them in plastic. At least, I'd say at least if you can get it, a gallon plastic bag full of it. And then the canned food would be frozen. And I have had a few cases with canned food. As far as bacterial, you're probably going to go with the frozen. It's not my area of expertise too much, but that's something that you do. And the other thing that FDA is going to have you do that's really important is chain of custody. And so fill out a chain of custody form, which basically says, who you are, who, the client name that had the pet, the sample, and all of the sample identification information, dates, initials, and things like that. And that would be passed with the sample wherever it went. So when you give it to the mailman, you sign off and the mailman signs it. And then when they take it to the lab, they sign off. Or when they take it to the post office, they sign off and the next person signs it. So you'll have this list of everybody who's touched the sample. And you also want to use tamper resistant containers with tape over them that will tear if somebody tries to get into it. And so are we having a decrease in aflatoxin due to grain-free diets? And I think because aflatoxin grows on potatoes, it grows on a lot of stuff that they're using in the grain-free diets. The product the sport mix product, I believe, did have grain in it, but I wouldn't assume that just because we have a grain-free diet, we're free of this. Plus, we get the cardiomyopathies associated with the grain-free diet. So it's a mixed bag, but I think there's been a lot of pressure between the aflatoxin outbreaks and the melamine outbreak a few years ago, almost 15 years ago now, for pet food industries to try new things. And sometimes it works better than others. So a little bit more about aflatoxin. I was telling you about this evil double bond here. So when you have this double bond on this aflatoxin that's kind of on the top left, the liver will break that bond. And so you have these two carbons here that used to be double bonded. And now you've broken the double bond and they'll grab an oxygen up here. So you have this triangular configuration where these two carbons are holding on to this oxygen over and it's an uncomfortable position. And you can see me, I'm not very comfortable doing this. And it's very uncomfortable for the carbons because they like to have squared. So they like it to be like this. And now it's like this triangular bond. They like 90-degree angles, but it isn't one. So this is very unstable. So this is going to fly apart the first time it hits a big molecule. And that's where we get into problems with aflatoxin. It particularly likes DNA. So it'll grab onto some DNA. So this is what it looks like when it's grabbing onto your DNA. So your little oxygen molecule moved over here and grabbed a proton, but it's stuck to your guanines here. It also reacts with proteins. Any macromolecule will do. It'll go grab a protein, it'll grab a phospholipid, anything like that. So it can disrupt membranes and whatnot. But the primary thing is the damage to the DNA. And since the liver is such an important organ when it comes to manufacturing proteins and just very metabolically active, this is a significant harm. And you get, eventually you get a crisis due to liver failure, vomiting, diarrhea, you can get jaundice. And a lot of times the major thing that you see is hemorrhage. And this is one of the things that was a problem in Texas because they were having a bunch of dogs bleeding out from their guts through aflatoxin, but at the same time they were having a parvo outbreak. So trying to figure out which dogs were parvo dogs and which ones were aflatoxin dogs was no fun. The ones that came in 2005 that I dealt with, they actually a lot of them bled out through the GI and a lot of them bled out through the lungs. So people were thinking it was a anticoagulant rodenticide, but when I see those liver enzymes up that were, well, actually the liver enzymes weren't so bad, but things like the synthetic enzyme, the synthetic products of liver, like protein C, coagulation factors, and cholesterol, those things were in trouble. Those things were declining. Oh, and somebody said that it might be true that the boutique exotic products, pet food products, have increased aflatoxin. And I would actually believe that, because I think the quality control standards are going to be a lot lower for those boutique products. They just don't, I mean, who's going to get an NIR in their little boutique grocery store to make sure all of their ingredients are up and up? So yeah, I think that's probably true. So diagnosis, you look at these, the liver enzymes generally aren't as high as you would think in these aflatoxin patients. It's mostly a synthetic liver failure, which is why you get the hemorrhage. So that's pretty much what you're going to see. Testing foods, the problem is from the time that they're first exposed to the aflatoxin until they break, it can be up to 3 weeks. And this is based on my experience of having like a dog that we found aflatoxin in the pet food and the dog was perfectly fine. And then 3 weeks later, it broke with aflatoxicosis. And obviously we had changed the food in that time. So it's an issue. It's a serious issue, getting a good sample, because a lot of times it's long gone by the time the animal shows clinical signs. And that was actually how we got the diagnosis in 2005, because the animals that had the worst clinical signs, all their food was clean because they had consumed all of the aflatoxin contaminated food. It was this dog that was on the same brand of food, but did not have clinical signs, that we found the aflatoxin. And this is just showing the massive liver loss. You have some pycnotic nuclei and some inflammatory cells in here. You've got lots of inflammation, a lot of fibrosis happening. And you actually see a lot of hepatic lipidosis in these guys, and it's kind of a microvesicular lipidosis instead of a macrovesicular lipidosis, which I find kind of interesting. And, you know, cell death, eventually you can get more of a cirrhotic kind of thing, but most of our dogs died long before that. So deoxynovalenol vomitoxin, this one is toxic at 4 to 8 parts per million, so much, much less toxic than aflatoxin, but it still can be a problem, and it's usually self-limiting. So I'm going to talk a little bit about some of the formulation errors that we see. And I already told you this. Does anybody remember which the important formulation error the most important formulation error that we see is? So it's thiamine, vitamin A, vitamin D, not in that order, but thiamine, vitamin D, vitamin A, or none of the above. Yeah, thiamine, I think, is underdiagnosed. It's true. I think thiamine is underdiagnosed, but the big recalls are usually vitamin D. So I think thiamine goes under the radar. Honestly, I think a lot of the neurologic animals that we never quite figure out what happened, I think they probably, because a lot of the pet foods contain very low concentrations of thiamine because it does break down during processing. And so a lot of animals are like on the verge of getting thiamine deficiency. And then you get one batch that has low thiamine and they start breaking with neurologic disease and they get a polioencephalomalacia. So elevated vitamin D in 2012, 2010, 2006, 1999, and there are sporadic cases all the time. And then in 2013 and 2009, we did see some thiamine deficiencies that were diagnosed in cats. Again, I think it's underdiagnosed. I would recommend that we small animal people be more like large animal people, and you have an animal with undiagnosed neurologic disease that's up on its rabies vaccinations and whatnot, just give them a B vitamin injection and see if that helps a little bit. Because these guys actually will recover incredibly well if they have thiamine deficiency most of the time. So this is cholecalciferol. And you remember basically that it's important for calcium and phosphorus regulation. And when you have too much calcium and phosphorus circulating, your kidneys turn into little rocks. If you've ever cut into the kidney of an animal that has cholecalciferol poisoning, you will not forget it, because it's really weird. It's like cutting through sandpaper. Your knife is going crunch, 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 crunch all the way through, and it's because all the glomeruli have turned into stones. And then this was another one that I worked on a few years back, quite a few years back. And that was a thiamine deficiency case. Thiamine deficiency is called a lot of different things in different animals. You may remember polio in horses and cattle, beriberi in people, chestic paralysis in mink, and polyneuritis in poultry. And how often is taurine deficiency the cause of a pet food recall? Again, possibly underdiagnosed. And I think most of the AAFCO regulated pet foods, you're not going to have a problem. The problems you're going to have with taurine are with people who want to feed cats a vegan diet. Taurine, and I saw one of you guys, you have that exam, and I saw one of the questions was about taurine, and I was kind of taking exception to it a bit because they were looking at taurine deficiency as a possible cause for the hypertrophic cardiomyopathy in dogs that are eating grain-free products, but they've never found a link there. They've actually tested the dogs, and they do tend to have normal taurine. It probably isn't a bad idea to supplement them anyway, but yeah, so I have heard of people, especially on homemade diets, having taurine deficiency issues in animals, and then there's the grain-free thing, which is a problem, but I don't think it's a taurine problem. I'm not really sure what it is. And I've been keeping up with the FDA releases and things like that, and they don't seem to know what it is either. So these guys, cats with the thiamine deficiency, however, and honestly, the first case of this I totally missed. And if it had been a cow, I'd have been all over it because they get these weird neurologic signs, head tilt, circling. And then you get to this weird place where they have a rigid paralysis of the limbs. So I'll turn around a little bit. So they have rigid paralysis of the limbs, but their necks flop down. And it's called the prayer sign, actually. And when they get to that point, there's not a whole lot you can do. But up until that point, blindness, circulating seizures, nystagmus, you can actually treat them with thiamine and they'll come back. So it's kind of nice. I don't know if this will work. Oh, it does work. This is a cat with thiamine deficiency. I am just tickled to death that this is working. So this cat, they gave her an injection of thiamine and she recovered 100%. This cat, his name was Oedipus. I remember this guy. Now keep an eye on his head, okay? So she's showing his neck's kind of floppy. It's hard to say because she's got her hand holding up his head a little bit to keep him comfortable. He's got this tetanic type paralysis, and she'll turn his head toward you at some point. That cat is there. The cat is mentally there. The cat knows what's happening. He's probably in a lot of pain because of the muscle spasms, but he's, you know, he's aware, he's alert. And unfortunately, this little guy, when you get that far, there's really nothing that you can do for them. So, so anyway, there you go. So polioencephalomalacia is really important. And of course, thiamine is super important for the citric acid cycle, etc. So just some lesions, paraaqueductal gray matter is hit really hard in the caudal colliculus, and they can actually pick some of this up on MRIs. So I know we've had some MRIs done here at some of these animals. And the treatment is thiamine supplementation, and they actually start recovering really quickly, just like the polio in cows, and they do extremely well, except if they get to the point where Oedipus was, where they're just in, you know, a really bad situation. And this is a case actually from overseas that I worked with on vitamin A causing hyperostosis in cats. So that was kind of an interesting one. And then adulteration, and this is a kind of a rare one. We actually didn't used to see a whole lot of adulteration cases. There was the accidental addition of polybrominated biphenyls to a whole bunch of livestock feeds in Michigan. And that was a disaster. Michigan's diagnostic lab did really well with that because it took them a long time to get the diagnosis. And when the state said, hey, why is it taking you so long to get a diagnosis? They said, because we don't have a very good toxicology lab. So now they have a really good toxicology lab. And this was 50 years ago, but they managed to maintain support. But they had to cull millions of poultry, tens of thousands of cattle, etc., because of the PBB contamination. And then we have the kind of the other accidental one that I could add here is the barbiturates. Rendered animal, a euthanized animal gets through the rendering factory and ends up in the food chain. And then intentional, and that would be fraud, and that would be melamine. So melamine is this thing that has a lot of nitrogen in it, and it's used as a polymer. It's used to make polymers for various uses, and particularly plastic. So if you have any Bakelite at home, I have some old Bakelite radios because I think they're cool. Those are actually formaldehyde plus melamine, and it forms a polymer that makes Bakelite. But the way that they test pet foods and other ingredient and pet feed ingredients and things like that for protein historically has been the Kaldal reaction, in which you measure the amount of nitrogen, and then you assume that protein is 16% nitrogen, and you use that calculation to determine how much protein there is. Well, if instead of protein, if you take something that for example, flour, and you want to sell it as gluten, you add a whole bunch of melamine, and then you throw off the calculation. You end up, because this got so much nitrogen in it, it raises the nitrogen concentration at your flour, and it looks to the feed chemist just like gluten. And in this particular case, in the case that happened in 2007, there had been other options at other times when this feed was, when animal feed had probably been substituted with melamine, but they actually used higher quality raw materials for this melamine. In this case, the melamine was contaminated with other things, including cyanuric acid and some other things that it turned out reacted with the melamine when they were in solution together. So dissolved in the intestine, gets absorbed, then they get concentrated somewhere else in the body. And where does stuff get concentrated in the body? It gets concentrated in the kidneys, right? So when it hit the kidneys, it bound to the cyanuric acid and melamine bound to each other, and you got this complex that formed crystals. So you get these crystalline structures in the kidneys, and that was what we had. That was the problem that we had. Nutritionists were saying that hair added to the mix also increased the apparent crude protein level. And that's true. In fact, I know there was almost a recall. It wasn't a recall, but there was an issue with a particular product that people were finding wires in it. It wasn't wires. It was actually shafts of hair and stuff like that. And there was some cause for concern that this was low quality stuff. And, my dog honestly doesn't care if there's hair in this meal. I mean, more hair. Okay, no problem. So animals ingest hair. I don't get too concerned about it, but yeah, hair does have a lot of protein in it. And the other question was, did we know that the stuff was toxic? We did not. We had never, I don't know if it's in here, but I was talking to another toxicologist on the toxicology listserv, and they were like, and somebody came up, it's melamine. And he was just like, Mela who? Nobody knew what melamine was. It was a new thing. This was brand new. They had done toxicology studies on it, and it was like toxic in grams per kilogram, not milligrams per kilogram, grams per kilogram. This stuff is like, 3 grams per kilogram, and you might see some crystalluria is what they were seeing in these animals. More toxic in sheep. And I imagine that's because of that small urethra, that the crystallization was causing blocked urethras and some of the male sheep. They didn't really explain what the problem was in the literature on that one. But the fact that this was contaminated with cyanuric acid, that was the key factor here. And actually, this had actually been seen around 2001 in Thailand, but it was misdiagnosed there. So I went back to find out more about it. And I actually figured out that I called the pet food manufacturer and said, remember that thing you had in Thailand? What happened? And they wouldn't talk to me. And I saw that the pathologist on that case was somebody I knew. He was down the hall. He worked down the hall. So when they wouldn't talk to me, I walked down to his office and I knocked on the door, and he came to his door and he said, the pet food company just called me and I'm not allowed to talk to you. So that was very frustrating, very early in the melamine outbreak. Very, very frustrating. And I'm not going to say what the pet food company is, but I have hard feelings against them. They're the one pet food company that I really have hard feelings against. I thought they were real jerks in that case. So this was what happened. We were involved because they were doing palatability studies. And they had a 20-year-old cat die at the end of the palatability study of renal failure. And so what? It's a 20-year-old cat. It died of renal failure. Big deal. But then another younger cat died a few days later. And eventually, several of the cats died from renal failure. We couldn't figure out what it was. I actually was hoping it would be leptospirosis. So I actually went down there, and that was the cleanest cat colony I've ever seen. They were beautiful. The animals were super friendly. It's just a really well-kept facility. I was so impressed with them. And we spent all this time trying to figure out what it was. We found these crystals. This is Brent Hoff, the late Brent Hoff from Guelph. And this was Dr. Goldstein, who was here at the time. These were just some of the urine crystals. They kind of really pretty. They look like hedgehogs or maybe broken dinner plates or something like that. So that was our clue. And this is Dr. Hoff did some scanning electron micrograms of them. And they're really pretty little crystals. And when we looked at the feed microscopically, I had a guy here that could actually, you could give him kibbles and he could tell you what they were made out of. It was he was amazing. We found these little bits of something, plastic or something like that. And there's a little ball of urea in there, but all these little fragments of plastic. And this is what the problem was. And these were the histologic lesions. You can see all these, the tubules have lost most of their mucosa. Most of their epithelium. There's maybe a couple epithelial cells trying to cling in there. Most of them have fallen off. The few that are left are trying to stretch themselves to protect that basement membrane as much as they can. And all the dead cells and maybe some macrophages are climbing into the center here. And this one's full of those little broken dinner plate crystals. And then you saw the results of renal failure. So you might see some uremic plaques and things like that. But it turned out if you gave these guys alkalized fluids, lactated ringers, they actually did really, really well if you could diurese them long enough. And then actually this happened in 2007, and I was asked to give a talk at my alma mater. So I went there to talk, and as I was leaving, I had NPR on, and they were talking about a bunch of babies in China that were getting renal failure secondary to a contaminant in baby formula. And I was like, wow, that's interesting. And I went to the talk, I went to the fall conference at my alma mater, and they were actually giving a Lifetime Achievement Award to Dr. Stephen Sundloff, who at the time was actually head of the FDA. And he is a veterinarian. And he was briefly in charge of the FDA until people found out there was a veterinarian in charge, and that caused some consternation. But I asked him, I said, did you hear about the thing in China? He said, yeah. And I said, is it what I think it is? And he said, yes, they've already diagnosed melamine as the contaminant in that particular situation. And it was like, wow, because those physicians are just way smarter than we are. It took us 3 months to figure it out, right? But it took them 24 hours. Well, it was because we'd already figured it out. And they just had to take the clue from what we had done. And so he put it, by 2008, we knew that melamine was a problem, and we knew why people were using it. So they were diluting the milk with water and adding the melamine to increase the apparent protein concentration in it. And literally heads rolled after this. The head of the dairy, the government head of dairy in China literally lost his head over this. They had him executed. What was really interesting is that in the children, you didn't have to have cyanuric acid, because it turned out uric acid would cause the same crystallization. It was slightly different because in the cyanuric acid, they crystallized in the tubules, like you saw in the pictures. Here it would crystallize in the renal pelvis and the urinary bladder. So they were a little bit more soluble. They made it a little farther down the tract. But it's the uric acid in urine of infants that seem to do it. So I got a few more minutes to talk about preventing contamination. This is one of the big questions at the beginning. And AFCO is really important in that, in the pet food industry. Training, maintenance, ingredients, packing, labeling, storage and inventory, inspection, record keeping. These are all different steps in the process, starting with cleanliness. So pest control, you do not want rodents in your factory. You don't want bugs in your factory. These things are strictly biosecure areas. And if you've ever been to a pet food factory, you basically have to wear a moon suit to get in there, right? Because they don't want your bacteria. They don't want anything off of you contaminating their equipment. So no rodents. This guy was a rodent that I found. I don't remember why I found him. Anyway, it was a deer mouse that I found around my house and managed to grab. I called him Sin Nombre. And I did not get hantavirus from him, but I kept him in a habit trail for a little while. He was cute. HACCP step 1, because I don't run a pet food factory, so it's okay if I have a mouse in my house. I think the cat had probably caught him and brought him to me, actually, at that point. So I kept him in the house for a few days to make sure that he wasn't going to get sick and die because of the cat. Then shoved him out the door. So critical control points, hazard analysis and critical control points. We consider what points of the manufacturing you can run into problems, and anywhere from ingredients, equipment, processing, storage, and distribution. Remember, I mentioned the aflatoxin in Texas, which was a distribution issue. It was the stuff that was being held in this hot warehouse where the aflatoxin became the problem. The original ingredients, all this other stuff was fine, but once they got to the storage problem, they had problems. So step 2, analyze potential hazards. So what hazards are high probability? Aflatoxin's high probability. Okay, it's a common mycotoxin in grains, and it can grow in other things, and it can grow in the field or it can grow in storage. But then and it also has a high morbidity and mortality. So it's something that you definitely want to worry about. Now, there are other mycotoxins, Deoxynovalenol, for example, and you do want to worry about it, but guess what? It's probably not going to kill the patient. Okay, it's going to make them sick. It's going to mess up the carpet, but they're probably going to be okay. So that is not as high a priority necessarily as aflatoxin. So control the hazards, step 3 and 4, with critical control points. So you figure out at what points you have to control these hazards. Number 1 for aflatoxin would be getting clean ingredients, right? And the last part for aflatoxin is making sure it's stored after manufacture properly. So, and then documentation, make sure you document all the ingredients, all the processes, make sure, you have documentation of the temperatures, as during the extrusion processes, all of the stuff, make sure that you're doing bacterial cultures of the equipment and having that all recorded. So you have to have really massive records. And a lot of this is automated in the larger pet food things. So it automates, the ingredients, what ingredients go in, when they go in, how they're mixed, how long they're mixed, temperatures, all of that stuff. So one critical control point, the raw ingredients. Check for natural contaminants, check for adulteration, check for formulation errors. This is a little bit farther down. Make sure your equipment is functioning properly. You do not want to have it accidentally forget to add the thiamine, or accidentally the valve opens too much for the vitamin D supplement and you get a huge amount in there. These are both problems that can happen. And also you have to know how much thiamine to add, because you have to add many, many times the requirement, because much of it is going to get cooked off during processing. So what do? You screen the natural raw ingredients. This is an HPLC that picks up mycotoxins and certain vitamins. There are test kits that you can do, for example, for deoxynovalenol or aflatoxin. And then most of them have an NIR, near infrared spectroscopy, that they will test all of the ingredients. And what it does, it's kind of like that. I don't know if I showed you the NIR from the melamine, but it basically fingerprints the ingredients. So it passes light through it, reads the spectra, and you have this line with a lot of peaks and stuff in it. So you get your ingredients and you test all of them as they come in. And then you go back to your records and say, okay, last time we bought corn gluten meal, the spectrum looked like this, and the spectrums had better match up. Okay. And if they had done this before melamine, they would have figured out there was something wrong with the ingredient. They would not have known what it was, but they would have seen that the fingerprint for that gluten meal did not match the fingerprint from the previous gluten meal. And that was where the problem came in. So now they're doing a lot more NIR on ingredients to make sure that they are what they say they are. And there's to kind of nip fraud in the bud a little bit there. Oh, here's a nice NIR. So this is one of the fingerprints from some specific sample. We used to do feed microscopy here. I sure wish we still did, but we don't anymore. But a good feed microscopist can give you a list of ingredients. They can look at the feed and they can take a piece of kibble and tell you exactly what is in there and in what proportions. They are just amazing. And then there's all these other things. We just got a new QTOF, so I'm very excited about that, but mass specs, high pressure liquid chromatographies, ICPs and AAs and X-ray fluorescence are nice for minerals. And again, with formulation errors, a lot of the equipment is automated, so you have to have excellent maintenance of the equipment to make sure it's not going to malfunction. You have to have excellent cleanliness, and you have to have records. And by the way, you actually have to read the records to make sure that everything worked. And then release the product. And then of course, pasteurization for keeping all of those nasty bugs out. Again, a lot of cleanliness and record keeping and reading your records to make sure nothing went wrong that you missed. And then monitoring all that recorded data, monitoring the recorded data, make it accessible at any time to anybody that should have access to it, and then reviewing and analyzing. A lot of companies are now taking their NIRs and taking their mycotoxin tests and things and testing the post-manufacture product, which is a really good idea. Because again, if you miss that hot spot of mycotoxin, you might pick it up later on. So testing to make sure the NIR reading is what it's supposed to be based on previous lots, and making sure that didn't suddenly some mycotoxins didn't appear because you missed them the first time. So when you have a process that when you have a problem, you stop the entire process, which is expensive. It costs money. Analyze records, consult, figure out what happened, and then figure out what to do with the product that's been damaged. Can you salvage it? Can you discard it? And this is a pretty important step because it's really expensive to get rid of huge amounts of pet food. I mean, they tried with the melamine, they redirected it to animal feeds for livestock. Boy, was that a bad idea, because now we had these livestock with melamine poisoning. And then we had the food chain issue. You can't eat livestock that died from melamine poisoning, or even livestock that was exposed to melamine at all, because of the possible food contamination issue. So that was a big mistake. So these things require a lot of thought. Is the pet food industry screening for or monitoring levels of the perfluoroalkyl substance, PFAs and PFOAs and all that stuff? As far as I know, they are not. I have there was some talk in New York about doing it because we have a very large area of contamination north of us, and it's also a very big dairy area. So the question was, actually for human food industry, do we need to test all the milk that comes out of those dairy cows? And I think at the time it was very early in the process of determining that we had these perfluoroalkyl chemicals out there, and nobody really knew what they were and what to do with them. And so the next question was, if you do detect these things in the milk, what do you do? So they said, can you test for it? And I was like, well, we could develop a test for it. If we find it in the milk, what are you going to do? And that kind of ended the discussion because they didn't know what to do. Thankfully, and that was the Hoosick Falls area, and it's been in the news a lot. And thankfully, dairy cows actually don't accumulate some of the, like, at least perfluorooctanoic acid. That was the big one then. Luckily, they don't accumulate it. So if you have them in a freshwater source, it won't contaminate the milk. So that's really good. So what do you do with the rejected product? It's a good question. And I don't know what the best way to do it. Mostly landfill, I think, is where it ends up. I mean, you can compost it with melamine, but the melamine's not going to break down. It's still going to be there. It's pretty stable stuff. So you're just putting it in the soil instead of in the food. Does FDA require HACCP for pet food? I think AFCO requires HACCP. I think AFCO has very strong guidelines. I don't think the FDA is, and that's where you get into the problems with boutique animal feeds and foods. So, yeah, and I actually didn't, there were some more recent, I think this is unfortunately an older version of the presentation than I wanted to have happen, because there were a couple, there have been a couple of interesting incidents actually in the recent years. There was, and they were, one of them was associated with a small boutique, and it was actually pancytopenia in cats in the UK. And it turned out that this shocked me. It turned out that it appears to have been T2 toxin, another trichothecene mycotoxin. And apparently cats are extremely susceptible to these. So I would have expected like a diarrhea like you'd seen with Deoxynovalenol, but no, they were getting pancytopenia, and it was often lethal. So that was one of them. And the other one, and that was a small boutique dealer. And I don't know if it would have been caught in a larger dealer. And of course, this is not an FDA issue either, because it's UK. And then in Australia, a boutique dealer was making a horse meat product that ended up having indospicine, a plant toxin that horses are resistant to, but dogs aren't. So they had enough issues with that. So that was pretty interesting. And somebody's put an FDA link on there. But oh, that's useful. Thank you. I didn't know that the FDA was requiring some PFAS testing. I know that I kind of didn't finish that story. Now, New York does have a perfluoroalkyl PFA type laboratory in Albany, and that has been gone in there. So yeah, the good pet food companies, the big pet food companies have really good HACCP management. The smaller pet food companies are not as good. So I mentioned barbiturates. There was a case a few years ago out west where somebody fed their dog a can of dog food. They had 3 dogs, and all 3 of them passed out, and one of them died. And it was because of the pentobarbital. And it turned out that this was a very small boutique kind of raw pet food place that just basically took slabs of meat off of animals and shoved them in a can and then canned them. And they had gotten a cow that had been euthanized. And basically all of the cans from that lot contained enormously high concentrations of pentobarbital, enough to kill dogs. And when the FDA went to investigate, they definitely did not have good sanitation. They didn't have good procedures. They didn't have good records. It was really a disaster. And I think this is something that's becoming more of a problem since the melamine and aflatoxin outbreaks, because people see that and it turns them off from the big the big corporations, the corporate, the Purinas, the IAMs and the Hills and things like that. It kind of turns them off of those, and they want to go to the more boutique because they think they'll have better quality control, and it's just not true. They can't afford to have an HPLC. If you're doing, boutique dog food, you're not going to have an HPLC. You're not going to have an NIR. You're not going to have good quality control. You might not even have very good sanitation and things like that. So, it's kind of a sad situation. And I think the big recalls have done a lot of damage to our pet food security system, in that they've caused some issues with what consumers are willing to purchase. And the problem, of course, with pet food is if you have a commercial pet food that's got some contaminant in it, or it's got some formulation error in it or something, if aflatoxin, right? A dog that eats 60 part per million aflatoxin for one meal is probably going to be okay. But when you eat it every day for 1 or 2 or 3 meals a day, 60 part per million aflatoxin, 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 60 part per million aflato that's when you get into problems. And, it's the same in other parts of the world where people have have a staple diet where they just use one staple food over and over and over again. They're getting, if that food is contaminated, they're getting repeatedly exposed. And I know as nutritionists, they say every bite an animal takes should be exactly the same as the last bite and exactly the same as the next bite. But it does have some drawbacks that we feed our animals like the same thing all the time. And when I was in Korea, I liked this poster. HACCP isn't just for astronauts. I haven't seen any information on cardiomyopathy associated with grain-free feeds in the public. And that's a good question because I've only heard about it with dogs myself. And I do wonder, especially since, HCM is not unheard of in cats as well. We just haven't seen it yet. It hasn't been associated with pet food though. So I have a cat that was just in yesterday for HCM. So he's our little miracle kitty. He had a saddle thrombus about a year ago and he's doing great now. So, and I guess, I went over time. I apologize profusely. If anybody has any questions, so I'd be willing to hang around for a bit longer.
So I'm looking at the question and answer feature and some very good comments about a great topic. Thank you, Dr. Bischoff. Excellent presentation. There is one question here from Dr. Tom Scott. Do you notice a difference in dog breed susceptibility to aflatoxin, small versus large breeds?
It's a good question. Small versus large breeds. I know. So the outbreak that I dealt with was mostly it was the first bunch was a kennel of Labradors, so they're a bit bigger. The most recent one was Cocker Spaniels, and I think the small dogs would probably be more likely just because more food per kilo of dog. They're going to eat a little bit more than the larger dogs. Growing dogs are going to eat even more. Pregnant dogs are going to eat even more. So all those things that might increase the exposure are probably partially to blame for the apparent susceptibilities of these guys. But I don't know any specific details on these dogs being. There's sure a lot we don't know about dogs and aflatoxin. Like I said earlier, the 1 part per million toxic dose is kind of bogus because at 60 part per billion, the dogs would have to eat like 0.5 kg per kg body weight to get poisoned, and it seems a little excessive.
All right. Well, with that, I don't see any additional questions, and we are over our hour, but it was a very engaging topic. I want to thank you, but as a final thank you, I want to turn it over to Dr. Suzanne Thomasy.
Thanks everyone for staying long, and a great presentation. And again, I thank everyone for coming. And if you have any requests for future speakers, we are still looking for later for 2022. Have a great evening, everyone.